Microservices are often blamed when systems become slow, fragile, or hard to change. The explanations usually go something like, we went too far, or we were not ready for microservices yet. However, in truth, those explanations hardly ever hold up. Most failing microservices systems don't fail because of scale or ambition. They actually fail because of a small number of organizational and design mistakes that early on seem reasonable, but then really compound over time. So today I just want to walk you through a few of these failure modes that I've seen repeated over and over again over the years across different teams, organizations, and industries. Number one, overly synchronous service calls. One of the earliest warning signs is when one request triggers a long chain of service calls. So service A calls service B, which calls service C, which calls service D, all to return one single response. And at first, this may seem correct, because after all, that probably means that every microservice is doing their own thing, and then calling other services whenever they need more information or to take different action. And that's fine, but the problem is that this creates fragile runtime dependencies. Take latency, for example. If one service slows down, then it ripples through all the other services. What about outages? Even partial outages can take the whole thing down and cause a full system incident. Not to mention that debugging becomes much harder because now failure is not local to the microservice anymore. Now, the important thing to realize though is that this is a symptom, not the root cause. If every service needs to call loads of other services to do their thing, that means you got your boundaries wrong. You didn't model your bounded contexts around the business capabilities correctly. So your decomposition looked great on the diagrams, but didn't survive real workflows. Now, this is where techniques like event storming can really help you uncover those gaps and mistakes and some uncomfortable truths. Because after all, your system is technically distributed, but conceptually tangled. Number two, shared databases and blurred data ownership. Another classic example is shared databases, and this one usually falls under the guise of pragmatism. I've sat on many architectural boards where I've heard the primary concern was that there were too many databases, and what usually followed was a conversation about how we were going to consolidate that data for simplicity or operational convenience or to reduce costs. And that's all fair enough thinking, really good intentions. But the thing is that this leads to a huge problem, and that is the lack of data ownership. Once multiple services start reading and writing the same data, then independent deployment starts becoming very risky. One service that requires a schema change can break all the others. So that means that teams start coordinating changes again, and that means that releases start becoming slow again. And that means that fear starts replacing confidence again. So over time, your system starts behaving like a monolith all over again, except that this time is even worse because all that coupling is hidden behind network halls and shared data. So your architecture looks distributed, but those constraints are very familiar. So patterns like database per service exist for a reason. It's not about purity. It's about protecting the autonomy of your microservices and protecting your architecture. Number three, unclear ownership boundaries. Ownership problems usually don't show up immediately. They build up slowly over time, typically with systems that are technically functional, but that for some reason you find it really hard to evolve or maintain, but you can't put your finger on why. A service may exist, but not one team feels responsible for it. So what happens then is that bugs start lingering on because not one person feels responsible for the fix. Improvements start getting deferred because everybody's looking at this giant backlog on a daily basis trying to pick things from it, which means that priorities are fuzzy. More dangerously though, is that architecture decisions start drifting because not one person has the authority to say no. And this is where DDD can be super helpful because the way teams communicate is just as important as services communicate. So DDD defines team communication patterns such as partnerships or supply and consumer relationships or separate ways. These are not abstract concepts. These shape how responsibility flows through the organization. If these relationships are not defined, then what you have is shared problems, not owned products. And finally, number 4, treating microservices as a technology upgrade. One of the biggest mistakes I've seen in my career is when teams treat microservices like something you install, not something that you adopt. Companies migrate to microservices, but then approval flows are the same, release processes are the same, organizational structures are the same, the architecture changes, but the way people work does not. So when you move to microservices, you really need to think about reshaping the way teams work. So, release processes allow teams to deploy independently without waiting on central gates. Approval flows stay close to the owning team, not spread across the organization. And teams should be trusted with that service end to end, from code to production. Without these changes, microservices just introduce complexity without unlocking autonomy. When microservices work well, it's not because of any given framework or cloud service. It's because architectural design leads to technical boundaries, which leads to team boundaries, which leads to ownership models, and they all reinforce each other. That alignment is what makes microservices systems easier to reason about, easier to evolve, and more resilient over time. Alignment is the real architecture. If you learned something new, then please like the video and subscribe, and I'll see you on the next one.